Good day. Today we are going to see about proportional integral controllers. There are three types of controllers: proportional integral controller, proportional derivative controllers, proportional integral derivative controllers. Okay, so controllers can be classified as three types, that is PI controller, PD controllers and PID controller. So PID controller is the combination of both integral and derivative controllers. Let's start from proportional integral controllers, which is called as PI controllers. So what do you mean by PI controllers? What are the uses of PI controllers? PI controllers are used to decrease the steady state error and used to increase the system response. So there are two things you are supposed to consider when you are designing a controller. So what are they? The controllers should be error free, or it should have a decreased amount of error, and the system response should be in an increased manner. Okay, so this PI controllers, that is proportional integral controllers, are used to decrease the steady state error and used to increase the system response. Okay, so this PI controllers are used to overcome the disadvantages of other controllers without affecting the stability of the system. Okay, so without affecting the stability of the system, this PI controllers can decrease the steady state error. Okay, and PI controllers, who are they are the combination of both proportional and integral controllers. So basically we have some other basic types of controllers such as proportional controller, derivative controller and integral controller. So when you put together proportional and integral, they form proportional integral controllers. So PI controllers are nothing but they are the combination of both proportional and integral controllers. Okay. So in other terms, this PI controllers is what? It is proportional. The symbol, it says it is proportional to the error signal. It is proportional to the error signal, which is called as E of t, and proportional to the integral of error signal. So what do you mean by integral of error signal? That is called by the integration symbol along with the error signal. Okay, so I will come again. The output of the PI controller must be proportional. Remember the symbol proportional to what? To the error signal. Error signal is represented as E of t, and proportional to the integral of the error signal. What do you mean by integral of error signal? It is represented by the integral symbol along with what? The error signal is denominated as E of t. Okay, so let's see how to formulate the equation based upon the definition which is shared here. Okay, also please remind that the output of the PI controller can be expressed as U of t. Okay, so when you're writing the equation, you may express it as U of t is directly proportional to error signal and what? The integration of the error signal. Clear? So now let us consider the output of the PI controller to be U of t, as we have discussed in the previous slide. Okay, the output of the PI controller be U of t, and the definition says it is directly proportional to the error signal, which is denominated as E of t, and what? The integral of the error signal, integral E of t. Okay, so this is going to be our first equation. Alright, U of t, the PI controller, is directly proportional to the error signal and the integral of the error signal. Now we are supposed to remove the constant. So in order to remove the constant, in order to remove the proportionality, we are supposed to introduce the constants, right? So therefore, U of t can be written as u of t is equal to, introduce the constant in order to remove the proportionality symbol, k dot e of t plus k integral of e of t, right? You are introducing the constant k dot e of t plus k dot integral of e of t. Okay, so in order to represent the error signal and represent the integration of error signal, we are going to write the same equation as kp. Kp is what? Constant, proportionality constant, and ki. Ki means, what is it? Integral of the error signal, that is integral constant. So we can write as where Kp is equal to proportional constant and Ki is what? It is the integral constant. Okay, so till now what we have done, we are removing the proportionality symbol by introducing two constants Kp and Ki, where Kp is the proportional constant and Ki is the integral constant. Okay, this is our equation 2. So now it is necessary to know the output of PI controller to integrate into the control system, right? For us to integrate the control system, we need to find the output of the PI controller. Also to compute with the block diagram to get the transfer function, we are supposed to proceed the above equation with a Laplace transform. So let us consider Laplace transform for the above equation. Then it becomes u of t, that is u of t is equal to kp e of t plus ki integral of e of t becomes u of s, right? So when you consider the Laplace transform on both sides, LT, on both sides, you can write the above equation as u of s, right? So this you are representing in frequency domain, right? So when you're taking the Laplace transform for the above equation, the equation is expressed in terms of time domain. When you put the Laplace transform for the above equation, it becomes frequency domain. So u of s is equal to, you won't be doing anything with the constants. So just like similar, kp, then e of t becomes e of s plus ki. You won't deal with the constants. Then integral of e of t becomes e of s divided by s. And you all know that the formula for Laplace transform of integral e of t is what? E of s divided by s. This is what? Formula for the integration of a time domain, right? So u of s is equal to kp e of s plus ki of e of s divided by s. Okay. So now you can take e of s common. You can take e of s outside. That means it becomes e of s into Kp plus Ki divided by S. Therefore, U of S is equal to E of S into Kp plus Ki divided by S. So, name this equation as 3. Now, we are supposed to find the gain of the system, right? So, gain of the system can be calculated by using the output transfer divided by the input transfer, right? So that means you can write this as U of S is your output transfer and the input or the error transfer is what? E of S. So in order to obtain the gain, you are supposed to write the output transfer with the error transfer or the input transfer, right? So that means U of S divided by E of S from the above equation 3. Okay. From the above equation 3, you can take E of S this side so that it becomes U of S divided by E of S is equal to Kp plus Ki divided by S. Okay. So now we are going to take Kp as common. So if I take Kp as common, you all know why I am going to take like this. We are supposed to write in an arrangement when you are writing the gain. The gain, it has a proper arrangements which it starts from 1 plus other terms. So always remember, in order to get that term, considering 1 plus other terms, we are rearranging it and we are writing as Kp. When you take Kp outside, it becomes 1 plus what else? Ki divided by Kp dot S, right? So that when you multiply this inside, what happens? It becomes what? You will be getting the same equation as of above, like Kp plus Ki times Kp divided by Kp dot S. So Kp and Kp will get cancelled. So you will get the same equation as above, right? So no more change. We are just making the Kp to be outside in order to get the arrangement starting from 1 plus other terms, right? So Kp, when you take outside, it becomes 1 plus Ki divided by Kp dot S. Okay. So now we are going to replace Kp by Ki is equal to Ti. Otherwise, or if it is confusing, just follow the same order. That is what? Ki divided by Kp, right? So Ki divided by Kp can be written as 1 by Ti. Don't confuse. Either you are supposed to write Kp by Ki is equal to Ti, or when you are inversing, what happens? The inverse is your answer, right? So Ki divided by Kp is equal to 1 by Ti. You may follow this to avoid the confusion. Okay. So what happens when you are replacing Ki by Kp by 1 by Ti? The equation becomes gain is equal to U of S divided by E of S is equal to Kp of 1 plus 1 by Ti dot S. You are just substituting the value of Ti from the previous equation. Okay. So this is going to be your gain of the system. Okay. So here I have drawn the block diagram of control system, which includes which controller? PI controller, right? So the input is what? The input is actually R of S, right? And then the PI controller value. It is what? It is actually E of S multiplied with the gain of the system. The gain of the system is what? The above equation Kp of 1 plus 1 by Pi dot S, right? So this is the gain of the system, which is what actually? Total PI controller's output, right? It is the total PI controller's output, that is what U of S, right?